In this question, we consider one natural phenomenon that is occurring, especially winter when we are breathing. Then you can see some kind of fog in front of the mouth. So the question is, depending on the temperature of the outside air, would we see such a fog or not? So here we consider that the air that is going out of the mouth has a temperature of 32 degrees and a moisture content of 90%. This is due to the fact that the air has been heated up by the body temperature inside the lungs, but also because everything is wet inside, there has been a lot of evaporation at the same time, so the air is very humid when going out of the mouth. First question is, will we see a fog if we breathe in air that is at 20 degrees Celsius? So we know that the ambient air is at 20 degrees Celsius, so somewhere on this line. Between here, that corresponds to a completely dry air, and here a saturated moist air. Here we don't know exactly what is the humidity of the ambient air. So let's think with taking the true extremum possible. So the true extremum will be a very dry air or a saturated moist air. If we breathe in a saturated moist air, the mixture between what we breathe and the ambient air would be a barycenter of these 2 points, so would be located somewhere in the somewhere on the segment between the 2 points. So I can plot this segment, and it would be somewhere there. It means that what we see here is that this segment is completely located below the saturation line, so all the states between the 2 points on the segment are describe a possible state of a moist air. If I take the other extremum from the very dry air to the air from the mouth, similarly, all the points from this segment are possible, so there's no chance of a fog to form because there will be no condensation. Now, next question is considering breathing in an air that is at 0 degrees Celsius. So, let me remove this. Now, we consider that the outside air is at 0 degrees Celsius. We still don't know exactly what would be the humidity of the air, but the maximum moisture content is anyway pretty low because the air is cold. So we can do the same, take the 2 extremum and plug the segment between the air from the mouth and these 2 extremum points. And what we see is that in both cases, this segment will cross the saturation line. What does it mean? In fact, the data points that are on this segment but over the saturation line do not correspond to possible states of a moist air. What is happening is that once we reach saturation, part of the water cannot stay as a vapor phase inside the moist air and will condense condense into small droplets that will be suspended in the air, and that's what we call fog. Let's take an example with an air that is, let's say, at 50% relative humidity. So that's more common than the extremum. And the segments will be like this. The place on the segments depends on the proportion we have from each of the air in the mixture. When you breathe just in front of your mouth, for the few first centimeters, the proportion of air from the mouth is very high. So the mixture point will be on this segment, but very close to the point corresponding to the air from the mouth. So from here to there, it's possible to do a mixture without having any condensation. So that's why for 2 or 3 centimeters we don't see any fog in winter in front of the mouth. Then if you go a bit further, the proportion of ambient air is increasing, and so it reaches saturation, and part of the water will be condensed into droplets. So in fact the mixture will not follow this segment, but will instead follow the saturation curve with some of the water that would be liquid. But when the proportion of ambient air is still increasing, it will be again possible for the air to contain more water vapor, and so the liquid water will evaporate again. And when we go further, these droplets are evaporating until it is again possible for the mixture to contain all the water as vapor form. And so that's why when you go several dozens of centimeters from your mouth, then everything is evaporated again, and you don't see any fog anymore because you're somewhere there on this segment.